I am so excited to be here today. I think BlendConf is doing a really wonderful thing. I'm really passionate about diversity, like gender diversity, racial diversity in tech, and I just really applaud their efforts. Just being in a technical conference and seeing women there is just kind of incredible. So here today, I'm going to talk about pedagogy and how to teach and teaching with JavaScript. It's something I'm particularly passionate about in my personal life and in my volunteer efforts. And so if you aren't aware, pedagogy is the method and practice of teaching, often from a research perspective or an academic perspective. Oh yeah, and one thing, actually. Follow me on Twitter. I'm at MarthaGirdler. I really love Twitter, and I love engaging with people that way. Pardon? Oh, okay. Okay, so about me. You may see my name on all of this marketing collateral as MarthaGirdler. That is incorrect. I'm actually Martha Schumann. I'm going back to my maiden name, wink, wink. So yeah, if you could look for me on the interwebs under Martha Schumann, and that's how you can find me and refer to me from now on. As I said on Twitter, I'm at Martha Kelly. I really, really love Twitter. Love to just talk with you about, I don't know, what's happening in the world that way. Yeah, and about me, I'm a software engineer at Uber, and I love my job. It's the best job I've ever had. We have a really strong Eng culture. I head up the Lady Eng organization. We do a lot of professional development and training. It's my personal mission in life to promote as many women who are currently in the industry as possible, and then increase the top level funnel with young women. That's just the way I think that we're actually going to make a difference. Yeah, and Uber's hiring like crazy. So if that's something you're interested in, please come find me, and I will get you the hookup with the appropriate people to make that happen. Okay, so why would you teach or mentor at all? We're all very busy. And why would I make room in my schedule to do this? Well, selflessly, a good reason would be just to give back. I've been given amazing opportunities in my life. I grew up in Alabama. I went to public school, and I was basically told throughout my entire time there that I was no good at math, I was no good at science, I was no good at physics, so you might as well study art. So I studied art and art history, which is awesome. My grandmother was an artist, it's something that's, important to my life. But they shortchanged me, and little did I know that learning math or writing software is not any harder than writing a paper. You just need the support system to be able to learn. And also, by volunteering your time to teach or mentor young people how to code, or not, they don't have to be young people actually, just anybody how to code, you can actually impact someone's life and encourage someone that's either a racial minority or a gender minority to participate in tech. I'm incredibly passionate about this because tech is where the jobs are. It's where the money is. And I fully believe that young women can take over the world once they get a hold of their professional life and they get a hold of their finances. So that's the next chapter of my life. Right now I'm focusing on getting young women to code. After that, I'll teach them how to master their finances. Selfishly, reasons that you might want to volunteer and teach someone to code. Well, it really helps you master the subject matter. Actually, even just giving a talk like this, you really don't want to look like an idiot, so you do a lot of preparation to be able to deeply understand the subject matter. And then another reason you might selfishly want to teach someone or volunteer your time mentoring is that you can greatly increase your own network of personal connections. I've met incredible people, even just here, even just in the first hour of being here, or a lot of the young people that I've helped get into school or get jobs, they just become your greatest allies. And those are the kinds of people that you really want supporting you back. So why JavaScript? Why would I lead with that? That's certainly not the academic choice. It's probably not the first choice that you might think of when you think of programming. But I'm actually really passionate about JavaScript, and I really think it's an appropriate first choice, or an appropriate choice for the first language that you might want to learn. And really it has to do with breadth of opportunity. If you understand JavaScript, you can write for the client, which is how many people get started. Everyone has a web browser that's very accessible. You can write server.js with Node, incredibly powerful. Actually, Uber, we have an amazing Node installation. Our entire dispatch system is written in Node. I do a lot of Node in my day-to-day. Unity. So if you're into the Oculus Rift, as I am, you can write Unity script, which is just JavaScript. or mobile web dev. Everyone has a smartphone with a browser on it. You don't have to write native applications if you don't want. But if you do, JavaScript can be converted into a plethora of different platforms, which is awesome. So there are a lot of different, platforms for developing with JavaScript that I'm totally forgetting. These are just a few of the ones I can think of immediately. So for me, it's more about access to jobs, access to opportunities, and I think JavaScript can really afford you a lot of flexibility. So when I was preparing for this talk and just preparing for my life in general, I read a lot of books about, or a lot of academic books about learning and how people learn and the psychology behind it. I have no scientific background. This is just something I nerd out about in my own time. But these are the two books that I focused on when I was preparing for this talk. So Improving Academic Performance is a really thick, expensive book, but it's really awesome, and actually I highly recommend it. It talks about the psychology behind a student learning something very difficult, or maybe someone who, or maybe it gives some particular insights into a student that might be marginalized otherwise, and the psychology behind some of their behavior, whether they withdraw, or whether they get frustrated, or whether they act out. There are a lot of reasons that a student might act that way. And it helps give you, as a teacher or a mentor, the tools to move them past that and to become an effective learner. So the second book that I read for this presentation is How Learning Works. And it's research-based principles just to be a better teacher. So whenever I talk about research or science, I'm basically referencing what I've read in these books. So after reading these books, there's a commonality that I found. The absolute most important thing about teaching is motivating your students. And I think you have to understand that they are not going to be motivated by what you're motivated by. Your students are complex people. They are social, intellectual beings. And they bring all of that with them to your classroom. And part of motivation, particularly with students who maybe don't have a technical background or didn't grow up with a computer in their house and they're not as comfortable with the idea of programming, they get turned off by it immediately, or maybe it's they won't even start to learn because they fear they're not intelligent enough. And this is actually my main cultural criticism of Silicon Valley, which I work for Uber in San Francisco. This is my life. There seems to be this weird complex that they think programmers are geniuses and they're hyper intelligent and that they're untouchable. I've met these people. That's so not true. Honestly, the idea of intelligence being something that's just endowed to you is just false. And the research absolutely indicates that. Intelligence is truly a combination of hard work and perseverance. So I'm going to talk more about that in a minute. But I think that's the number one thing that we have to overcome when we're teaching young people how to program, is that they are smart enough. They've always been smart enough. And you can actually get smarter. You can become more intelligent with hard work. And one thing that is a strong demotivator for a lot of students, me included, is stereotype threat. And I'll go into more detail about that. But that's basically where you are just deeply aware of the stereotypes against you, whether it's your gender or your race, and you're just very distrustful of the people teaching you, and you're distrustful of your own ability to learn. And that's something that you have to overcome in order to create the kind of student that will teach themselves and be successful. So the other part of learning is this idea of mastery. You want to take your students from the mindset of a novice to the mindset of a master. And there's a lot of different stages involved in gaining mastery, and I'll talk about a few of those and how to leverage them as you're teaching. Okay, motivation. This is the single largest factor in a student's success. Do they personally believe that your coursework will impact their life beyond this course? Do they think it will actually lead to them getting a job? Do they see a clear path to success? If a student can't see a clear pathway to success, they won't even engage. So some professors might start their class saying, only a third of you will pass. That's a terrible way to motivate your students. Maybe that would personally motivate the professor, but that's where you have to step out of your own shoes for a minute and realize that what motivates you, maybe if someone challenged you that way, that really made you work harder, that might not work for your students. That might actually intimidate them out of even trying. What we want to do is create students who try fearlessly. We want them to not be afraid of failure and to think of failure as something temporary and something that with hard work and more preparation they can overcome. So another thing about motivation or motivating a student is altering their view of intelligence. Like I said, there's this like very damaging view that like some people were born really smart and some people were born not very smart, and like that's just already predetermined and there's nothing you can do about that. I am proof that is just so not true. I spent the majority of my life just like, I've struggled with mental illness and depression, and so in growing up in a household where I didn't have a lot of support, I did terribly in school. I was like a C student maybe, but I was incredibly smart. It's just like I didn't have the support structure that I needed to like really just run with this and believe that I can do it. It's absolutely a confidence issue. And what's interesting, I should probably tell you a little bit about like how I learned to code. That might be helpful. I studied art history. I graduated in 2008, couldn't find a job. It was like the beginning of the recession or it was like in the middle of the recession before we were actually calling it that. And so I started to learn HTML and CSS because I saw there were web dev jobs. So I learned that, thought it was awesome, learned a little bit of JavaScript, thought that was awesome, heard about a school in New York called Hacker School, where it's like a 3-month workshop that teaches you how to program, and I straight up lied to get in there. Like, they're like, do you have programming experience? And I said, yes. And they're like, okay. And then throughout, like, just, I don't know, hearing about the program, I knew they were going to ask me to write a FizzBuzz, which, if you're unfamiliar, that's like a very simple programming test where you have to print out numbers, and at different multiples of 5, you print out fizz or buzz or whatever. So I just straight up memorized it. I just like memorized the syntax, and somehow they still accepted me. But what turns out is that, so that was 2 years ago. 2 years ago. And I'm doing incredible things with my life now. I'm just like a full-fledged software engineer. I'm not junior. I'm really productive. Anyways, I'm giving you that background to know that like a student can change the course of their life in just a matter of a year. There's a lot that can happen. And it really takes them believing in themselves and you believing in them and their potential. You have to set high expectations. Even if it's an underperforming a child or student, you can't lead with that assumption. You have to believe that they can do better, and then they will start to believe they can do better. And the other thing about motivation is like this fear of failure. This happens for really like smart children or children who are told they're smart a lot, and maybe children who are told they aren't so smart. The children who aren't so smart fear failure because it's going to confirm everyone's suspicion that they're not smart. So they won't even engage or try. So you need to create an environment where it's okay to fail and that failure isn't negative. In fact, it's like a learning opportunity. There's this like old saying, it's like sometimes you win, sometimes you learn. I think that's something really powerful that you can bring to your own classrooms or to your own mentoring relationships. And then like really smart kids, like they may freak out and like crumble under pressure because it's also going to confirm to people that they're not as smart as people think they are. And I think that happened to me as a child, so it's certainly something that I like identify with. Part of like, I actually forgot to put this in my slides, so I'm just going to wing this part. But one thing you can do to help motivate your students is be very careful about what kind of praise you give them. It's very common to be like, oh, you're so smart. You made an A on that test. You did a great job. Or like what have you. But like honestly, praising a student based on being smart is damaging. And it can reinforce those same like problems of like motivation where you're worried that like you're gonna be found out for not being as smart as you are. So actually, a better way to motivate your students is to congratulate them on the hard work they did to achieve that grade. Focus on the work that they did, because that's something they can control. All right, so as you're teaching, it is your goal to create a student that is eager to learn, loves challenges, and is able to persist in the face of difficulty. These are the 3 metrics in which you should gauge your own success as a teacher or a mentor. Because this will set them up for success in everything that they do. Not intelligence, not whatever kind of other advantages somebody might have. Honestly, if you can persist in the face of difficulty, and if you don't back down from a challenge, you're not afraid of trying and failing and trying again, you will achieve your goals. And that's something that we need to be teaching these young children or these young people. It's very true that children become what they think they are. If they think they're not smart, they're not going to even try. But if they believe they have the potential to change their destiny by just trying really hard, they will. Or at least they'll try. And then one thing that you can do is set them up for success with small goals that are very achievable that you can provide direct feedback. So let's say they've never written a program in their life. And you're like, okay, I want you to go and research about what a variable is, and I want you to tell me about it. That's so simple. But they need that one piece or that one feeling of success so they can build upon it. And it's very important in the very beginning that they have a big wow moment where they're like, I can do this. Because beliefs can be changed. These children's beliefs about themselves can absolutely be changed with your intervention. Okay, stereotype threat. This is something that is very real to me because I work with a lot of men, I always have, and I'm always worried about not being smart enough, or here I am, like, you know, it's like this is the very common like psychological issues, or I'm worried that if I make a mistake or if I'm not like the best programmer in the organization, that they're going to think all women are terrible programmers. And I can only imagine, you know, like people that are in the racial minorities. I cannot imagine the amount of pressure they feel to succeed, and I could totally understand the not even trying part, rather than risking failing that publicly. This is suppressing minority achievement. I wonder if I wrote. There's an experiment that they did that I thought was really interesting, where they had the control group and then the experimental group, and it was just a mixture of all different, like, it was actually white and African American students, college age, and they were given a standardized test, a very challenging one. They're split into two groups. In the control, they said, we are here to monitor your performance and your academic ability. In the other group, they said, we're not interested in how you perform on the test. We're just studying how you process it, how you're processing the verbal portion of this test. So very different expectations. What they found out in the experimental group is African American students answered twice as many questions successfully because they weren't worried about being perceived as unintelligent. So that's why when we're teaching students how to learn effectively, we need to like foster this idea of like valuing learning for its own sake rather than like how you're perceived. And that's very hard. And it's actually a disturbing trend I'm seeing just in like public schools in general is that they're very test score based. And that's like how you receive funding, and that's like how you're judged. And like as a teacher, that's how your performance is evaluated. And I think that's really damaging. And like, Farina, there's something I can do about it. And hopefully there are creative teachers in this room who can think of creative ways to maybe get around it. But that's certainly something to keep in mind. So the thing about stereotypes is by the age of 5, every human is aware of stereotypes. It doesn't mean they agree with them, it just means they are aware of them. And it turns out, the research indicates, all you have to do is just be aware of the stereotypes to have it impact you and to affect how you're biased. So this is something that you really need to be careful of, particularly if like you're a white teacher mentoring an African American student, or if you're an African American teacher mentoring a Latino student. You have to be aware of the stereotypes that could affect how they perceive you. You know in your heart that you're doing everything you can to not be biased, but they don't know that. They have a lifetime full of negative experiences that tell them otherwise. So building trust with the people that you're mentoring is also like paramount importance, because if they don't trust you, they won't listen to you. And that really takes like forming a personal connection with them and a lot of patience, because like I said, you are trying to override a lifetime worth of negative experiences with this one positive interaction with you. Okay, so how to combat stereotype threat? Have high expectations. I mean, granted, you don't want to like freak them out and then say like, if you know, I expect you to get an A in this course, but you need to say, I believe in you. I believe you are capable of this, and this is what I want you to strive for because I believe you can do it, and I'm going to, monitor your progress along the way. And if I see you slipping, we will work on it together. The other thing, as I said earlier, you have to create trust. They're very vulnerable. This is something very, like learning to program particularly is quite daunting if you didn't grow up with it. That's another thing that really bothers me about like Silicon Valley is that a lot of these men, these white men, grew up with computers in their house. They've been programming since they were 12. It's just a different game. Like they aren't smarter than the rest of us. They've just been doing it for 20 years. So I think that's another thing that maybe you could relate to your students. Like, you've been doing this for what, like a month? Like, don't judge yourself based on those standards. I wish you could see, like, the crap code those kids were writing when they were 10. Like, it's probably comparable. Another thing you can do is just create a new view of failure. I think we all could, like, stand to benefit from changing our relationship with failure. Because we have such a performance-based culture. I mean, it's, like, natural that would be our response. But I think if we work together and start to value your personal development and just your love of learning over like your academic performance, I think that could go a long way. And like really instill in them over and over this new view of intelligence. That intelligence is not something given to you. It is something that you can create. And here's some proof that intelligence is not fixed. I really love this, actually. Darwin, Tolstoy, William James, who's like one of the founders of like modern psychology, Mozart, and Michael Jordan were all deemed failures as children. Michael Jordan was even cut from his high school basketball team. And he used that to become better. And I think it's really important for children to have these kinds of examples. That some of the, like Darwin particularly, his own father told him, you won't amount to anything. As a child, like he thought he was like dull. Yeah, intelligence is certainly is a product of hard work, and I think that's something that we should value more. Okay, so as a teacher, something that you really need to start instilling in your students is the self-efficacy and mastery. So self-efficacy is this ability, or is this feeling that they have about themselves to say, I can do this. This might be a scary challenge, but I can do it, versus saying, I can't do this, I'm not even going to try. So like, when I was talking about the metrics in which you want to evaluate yourself as an educator, you really want, like, at the end of their time with you, you want them to be able to not shy away from challenges because they have this history, this like whatever year-long history of small successes along the way to prove to them that they can do this. So like, the one way to build confidence is to have these mastery experiences. And the way you create mastery experiences is by building on the last thing that they learned and incorporating it. So whenever you introduce new coursework, link back to the lesson you just taught and talk about the relationships between the two subjects. So this idea of mastery is going from like a novice to someone who doesn't know very much about the subject matter to becoming like the master of the subject domain. There are 4 general stages that these researchers have found in achieving mastery. I'm only concerned, at least for this talk, about the first 2 stages, because I kind of believe that is the instructor's role, is to like help foster the part of their development where they're acquiring this like individual component skills. And so like in the context of JavaScript, what is a variable? Really understanding what that means. Like, what is an array? What is an object? What is a function? Those are component skills in isolation. And like, you really have to understand those basics backwards and forwards. It has to be second nature before you can move on. To step 2, which is where you're practicing integrating those skills together. So that might be, so how is a function an object, but a little different? And how can functions be passed around as an object would be passed around, and why is that? So those are the kinds of questions that when you're in stage 2 that you should be asking. In my opinion, those probably aren't the kinds of subjects you want to bring up when they're first learning. I don't remember. Yeah, okay. Yeah, I have an example of a way you might develop your curriculum. But of course, I have no idea if this actually works. This is just like my hypothesis. But when they're acquiring the component skills, you really want to drill in why JavaScript is important to them. Because if you don't create that value proposition, they're not going to care. And they're not going to try really hard to understand it. But if you say, hey, did you know you don't have to go to college and you can still be making $100K a year writing JavaScript? Maybe this is something you should consider doing more of. And then showing them how fun it is. Like, JavaScript is really interactive, particularly like people who start programming with client-side JavaScript. You can see immediately, like, the feedback loop is so like short between what you code and when you refresh your browser. I think that's really powerful. I think it's important for students to understand how JavaScript works in the browser, because this idea of gaining mastery is about creating this mental model of connections. And so it's like this giant map with all these nodes, and they're starting to form these little connections. But in stage 1, they just have a bunch of little nodes, and they don't really see the connection between all of them. So you want to provide more context. And that's actually the difference between the way a novice assimilates information and the way someone who has mastery over the subject matter assimilates information. Someone who has a master over this, like over JavaScript or programming, has all these connections. It's high resolution, like a lot of nodes in their mental model of like what they're building. Novices don't have that. And so when actually you're teaching the subject matter, you have to think about it that way. You have to think about it as a novice, as someone with without all of the experience that you have to know the connections between all of the different pieces. So when you're organizing the information in your coursework and in your syllabus, it's very important to like be able to isolate and deeply understand the different nodes and then worry about the connections later. But you have to keep pulling in the different components as you're learning about the connections, because the way that knowledge sticks, the researchers have found, is it sticks to other knowledge. So if we can say, oh, so now you know what a variable is, did you know you can store arrays in a variable? All right, let's learn about arrays. Let's start storing them in some variables and see how we can access things inside of an array. That's the kind of progression you should take in your coursework. So in step 2, I think it's incredibly important to learn the debugger maybe first, and maybe learn how to like poke around in there, like the console, like if you're teaching client-side JavaScript, and make them aware of the different kinds of common error messages that could be thrown. Because like you spend the majority of your time as a programmer debugging why your code isn't working. So I feel like the mastery over what kinds of errors are common errors. I think that's super important to like lay the groundwork. And then learning the basic kind of like types. I kind of talked about that a minute ago. And I wouldn't even worry about logic or scoping or any of that until they have the other basics down, because logic gets confusing. JavaScript isn't totally intuitive, and it doesn't act like a lot of other languages. Particularly scoping is something that they need to understand, but probably not in an intro course, because it's just a little kind of weird. So when you're in the stage 2, where they're practicing integrating all these little like components that they've learned, that would be when I would recommend they write their first actual program, rather than like little isolated little bits that don't really like necessarily have to execute as like a full script. You can create small, well-defined tasks. Cones are really great for this. So a cone would be, you could have like a test suite running with a few failed tests, and they have to go and make them pass. So they only have to tweak a little thing here or there, but they get to learn why the test failed or why this error was thrown as they're making it right. And I think that's an incredibly effective teaching mechanism at this stage. And I really wouldn't include jQuery until at the tail end of this, when they're about to jump into their own and like start learning more on their own. Because I think one thing that blows students' minds is when you see the $sign in jQuery, it's a function. And like that's like, I think that unless they understand what it really means to have a function and to pass arguments into a function, I don't think they're going to really truly have the mental model to be able to understand jQuery. So when you're helping coach your students to achieve mastery, you have to assess what an appropriate level of challenge is at each stage, and that's incredibly difficult. I'm not going to pretend that that's easy. That's something you'll have to experiment with. But if a child is too confused or feels too lost, then they'll give up. Yeah. But if you build at least incrementally on their previous learnings, I think that you can mitigate a lot of that. Yeah, and just like, I know I've said this over and over, but it's maybe just because like I need to hear it. But yeah, redefining our relationship with failure is also crucial, because if I don't know how many are programmers in this room, but like we fail all day long. Like that's all you're gonna do is just write stuff that doesn't work and doesn't work and doesn't work, and then finally it works, and it's like glorious. But yeah, that just needs to become the expectation that doesn't mean you are bad. That means you're doing something and you're learning. Okay, so an effective teaching strategy when teaching JavaScript would be elaborative interrogation. So that's a very fancy word in like the academic world. But basically, if a student comes to you with a problem, you ask them why. Like, why do you think this is happening? Or if they learn a new concept, you say, well, tell me how that could be applied potentially. Another effective teaching strategy or analogies. This is incredibly important in programming because it's kind of abstract, and you need to be able to create practical applications into their world. But one thing about that you should note about when you're providing analogies is give a lot of different ones. Because your analogy is going to be limited if you only give one. That's only giving like a part of it, or a part of like the concept you're trying to teach. But if you provide tons of them and also contrasting analogies, then that will give them more context in which to actually fully understand what you're trying to teach them. This is something that's interesting. I think I blew through my slides, which is par for the course with me. But I think because I have only like 2 slides after this. But a really important distinction to make in learning, and this is why I really just dislike the testing culture like in America's school systems today, is like there's a difference between declarative knowledge and procedural knowledge. So declarative knowledge is what I was really good at in college, where I can memorize tons of stuff, regurgitate it, immediately forget it. Procedural knowledge is more of the how. It's like how you make those connections. And that's the kind of learning that we should be valuing in our students, not the can you name 50 states. Cool. All right. Well, I mean, I'm sure that's valuable. I mean, don't get me wrong, but like there are probably other more interesting things they could know about the states. Okay, so here is some more, or another idea for you if you're an educator in the room or if you mentor people, how you want to define your own success in this mentoring relationship that you have. You want a strongly motivated student. They need to be just intrinsically motivated to, when they leave the classroom, to keep going and to do this on their own. Because if you have a career in programming, you know we're constantly learning. Things are changing, particularly in front-end dev. They change every day. There's a new CSS something, a new HTML something, new JavaScript something. So that's just like something that needs to become part of like their identity. You want them to be confident. It's incredibly important that they believe in themselves. And they need to demonstrate procedural knowledge. So they're probably at that point more towards stage 2 where they're starting to make connections. I wouldn't necessarily like expect them to like have a high degree of procedural knowledge like when they're just learning the components. But when they leave your course, like certainly. Yeah, and you want to make sure they can learn independently. That's incredibly important because they need to be able to pick up where you left off. So thank you. I have tons of other things to say about this. A lot of other examples that I didn't include in the slide deck because I was afraid I was going to run out of time, but I talked really fast, which is kind of how I do these things. But I'm happy to take questions. In case you're wondering, another thing, I should probably give you some context about myself. So I do a lot of teaching. I work with Girls Who Code. I work with Hackbright. I put on Hack Days. Hackentine's Day was something I did where we created Valentine's Day e-cards, and there are 3 different tracks where I provide the HTML and CSS for you, so it looks really awesome. Then you just have to write the JS. You just have to comment out pieces of the JS and like tweak values to be able to have the animation work. I think that's a really like low friction way to get that wow moment where like I did something awesome. Like I want to continue with this. Like I see the value of this now. And then there's a second track where there's no JavaScript included and you have to write it yourself. And then the third track, we created a Python Twitter bot that would like scrape the Twitter feed for certain like identifiers. Like the one I did was like bad day. Like so if it finds the words bad day in the Twitter stream, it'll like shoot you a link to a card that says I hope you feel better and I hope your day gets better. And then I also did like Ladies Hack Day in Nashville, which is the same concept. It was just for Mother's Day. So like the e-card idea is like really flexible because you could do it around any holiday or not, I guess. And that's like a really accessible kind of project, like an entry-level project to kind of get, used to the idea of programming. I kind of joke that like, I may be a software engineer by trade, but I'm a teacher by heart. And so it's something I'm incredibly passionate about. And the only way I'm gonna be able to walk into an office and not feel completely alienated as a female programmer is if there are more of us. So I will do anything to make that happen, and I hope you will help me.